Hi guys, in this video I am just gonna go over just quadratic inequalities. I'm gonna do the two different types really, but it's all the same concept. I'm just gonna try to make it brief real quick. It's the first day back, and also it's just kind of this random topic that we're gonna go over, so we're not gonna spend too much time on it. But here's the idea. It says sketch the graph of each function. And you have y is greater than or equal to 2x squared. So as far as just being able to do this real quick, I'm going to go into my calculator menu. Let's reset the window real quick to standard. I'm going to type in. Now a lot of people will actually go back on this. They'll delete it. They'll press Control equal and they'll insert the sign that they want here, and you can see that there's like a equal to or greater than sign right there, but I'm not even going to do that. I'm just going to keep it on equal to, and then I have 2x squared. So equal to 2x squared. So 2x squared is just the x squared function, but it's stretched by 2. So it's just the x squared function, and it's stretched by 2. Okay, so I'm going to go ahead and graph that on my other graph real quick. Right here. Okay. So x squared function stretched by 2. If you wanted a more specific graph, you could actually look at the table. These are the points that you'd find that it goes through. So we've already graphed lines before, and a few things that we're going to want to keep in mind is that when it's greater than, equal to, or less than or equal to, when it's got that line on the bottom, that means it's going to be graphed using a solid line. And then when it's strictly greater than or less than, then it's going to be graphed using this dashed line. So that's something that we need to keep in mind. Okay, so the question now is on what side of this line do you shade? So remember, there's graphing the line itself, which is solid or dashed, and then there's shading the line. And I told you guys the easiest way to do this is probably just plugging in a point. So if I take any point that's not on this line, so for example, here's a point that's not on the line. Let's say 2, 0 right here. That point is inside of this parabola. So I'm going to take the point 0, 2, and I'm going to plug it into this inequality. So if x is 0 and y is 2, then I'm going to have 2 is greater than or equal to 2 times x is 0 squared. So is that a true statement? Is 2 greater than or equal to 2 times 0 squared? Well, 0 squared is 0 times 2 is 0. So is 2 greater than or equal to 0? Yes, it is. So I'm going to shade on the same side as the point. If that were not a true statement, it is a true statement. But if it were not a true statement, I would shade on the opposite side of the point. So I'd be shading on the outside of this parabola. But because it is a true statement, I'm going to go ahead and shade on the inside of the parabola. Something like that. And that'd be fun. Okay, let's do one maybe slightly more complicated. These are all pretty simple so far. At least they look pretty simple. Let's do one of these. Okay, so I've got, let's do x squared minus 6x plus 11. So I'm going to go ahead and graph this one. X squared minus 6x plus 11. So again, I'm just going to, there's a few things that you should know about this already. One is that it's going to be facing up. Also, I don't think, this does not look like it's factorable. You'd have to find two numbers that multiply to be 11 that add to be negative 6. And I don't think those exist. You could do something like the quadratic formula to solve this. But for now, I'm just going to plug it again into the calculator because I don't want to, I've already explained how to use the quadratic formula and all that on previous lessons. Okay, so we've got x squared minus 6x plus 11. All right, I'm going to go ahead and get some more specific points because I don't really know them. So I'm going to go from negative 2, which is at positive 27. That's huge. Actually, this graph, if I'm looking at this graph right here, it goes from 0 and it goes to the right. So I'm going to go from 0 as well. maybe even 1. I'm going to go 1, 6, 2, 3. Yeah, let's do it that way. So I've got 1, 6, because that fits on here, 2, 3. There is 3, 2, 4, 3, yep. And it's going to be 5, 6, just because I know this thing is symmetrical. It's less than or equal to, so again, less than or equal to because it's got the line on the bottom. We're going to graph it as a solid line. Remember, if it's strictly less than, then we would do dashed line, but it's not. So it's strictly, or it's less than or equal to. So I'm going to go ahead and do a solid line like this. And now the question is, do I shade on the inside or the outside? So again, take a random point, any point you'd like that's on the inside or the outside. So here's a really easy one. If you look right here in the bottom corner, you've got 0, 0. Let's use that point. So I'm going to take the point 0, 0, and I'm going to plug it into this inequality here. So if that's true, then y is 0. So 0 less than or equal to 0 squared minus 6 times 0 plus 11. So notice for all the y's and the x's I put 0 and 0. So I have 0 is less than or equal to 11. That is a true statement. So again, I'm going to shade where the dot is. So notice the dot's on the outside. This is a true statement, so I'm going to shade where the dot is on the outside. In this case, if it were a false statement, I'd be shading on the inside. And that's the idea. Maybe, well, let's skip out on this one now. So we're done with this paper. I'm going to go ahead and grab another paper real quick just to go over now a slightly different concept. It's the same idea. It's really the same idea, but slightly different format of question. So this is pretty ugly on the right side. This is just kind of scratch paper for you guys to use. I'm going to do it separate up here on the top. So say this is my graph. Okay, now the question is, when is this inequality greater than 0? When is this inequality greater than 0? And say you have it, if you're doing a problem like this and you have it equal to some other number, like when is that inequality greater than 8, then set it equal to 0 by subtracting the 8. But anyway, this question is just simply asking, when is this inequality greater than 0? So let me go ahead and graph it. You can graph it on your calculator, or you can just graph it if you notice that this is actually factorable, which it is. So it's -2. -2 times -4 is +8. -2 plus -4 is -6. Greater than 0. Okay, so it's actually a pretty easy concept. I'm going to zoom in on this real quick right here. So the concept is pretty easy. What I'm going to do is go ahead and graph this. I could do that on the calculator or by hand. Right here you can see me doing it by hand. That means it's going to be hitting at +2 and at +4. So that's +2, +4. It's going to be facing up because the a value here is positive. So it's going to look something like this. Might look something like that. Remember, this is +2, +4. Okay, so where is it bigger than 0? So notice my graph becomes bigger than 0 right here at +4, and then anything up. So anything, when x is anything, when the x values, so remember x values are running this way, when the x value is anything bigger than 4, when x is bigger than 4, it's bigger than 0. This quadratic is bigger than 0. And when x is anything less than, when x is anything less than 2, my quadratic is bigger than 0. Let me go ahead and do one more. So let's see. I'll go ahead and do this one right here. So if I factor this, let's see if I can. Got 7 x squared plus 3x minus 4. So +4 times -1 is going to be that +3 in the middle. So 7 x plus 4 x minus 1. Okay, so when I graph this now, let's see. Again, I'm just going to do a kind of a junky sketch. So at -4, it's going to cross, and at +1, it's going to cross. And this is just all estimation, as you can see. We know it's facing up because the a value is positive, so it's going to look something like this. And remember, this is at -4, and this is at +1. And the question is, when is this inequality right here? When is that quadratic function that you see right here, when is that going to be less than 0? So we just graphed it right here. Here's the graph of it. When is it less than 0? Anywhere from -4 all the way to +1, you see the graph actually dip below the line where it's less than 0, where the y value is less than 0. So anywhere from, let's see if I can get some space over here. There we go. When x is greater than -4, you can see it right here. X is greater than -4, but less than +1. But less than +1. Something like that. Okay. So again, this is just, it's going to be kind of a brief, kind of random thing that we're learning, but it would probably benefit you to understand this and learn how to do it. All right, I'll see you guys in class.